Hello and welcome to the Paper 1 non-calculator paper from 2023. So this was the non-calculator paper for Thursday the 4th of May 2023. We're going to go over this question by question. There's 35 marks in total for this. So question 1. Josh earns £9 an hour and works 30 hours a week. His weekly outgoings are £220 per week. Josh saves all his remaining money. He books a holiday costing £566. He'll take £800 spending money with him. Calculate the minimum number of weeks it will take him to save the total amount. This is a 2-mark question. So he earns £9 per hour and he works 30 hours a week. So the first thing I'm going to do is calculate how much he earns in a week. And this is just 9 times 30, so £9 times 30. Well, if you know 9 times 3 is 27, just times that by 10. So we're going to put £270. The next part of this is his weekly outgoings are £220 a week. So we need to subtract his outgoings from that. So we're going to minus 220 from that, and we're going to have £50. So we're going to have £50 savings per week. Okay, so let's see how much his holiday costs. So what does he need to save up to? He books a holiday costing £566 and he'll take £800 spending money. So let's add those two up. We've got 566 plus 800, and that comes to £1,366. Now we need to figure out how many weeks it'll take him to save this amount. So we need to do 1,366 divided by 50. So there's a number of different ways you could do this. What I'm going to do, instead of doing 1,366 divided by 50, I'm going to do 136.6 divided by 5. I've just divided both by 10. It will give you the same number. So how many 5s go into 13? We're going to have 2, and we're going to carry that 3 there. How many 5s go into 36? It's going to be 7. And I'm going to carry the 1. How many 5s go into 16? It's 3. And as we can see, we are over 27 weeks. And so we're going to have to round up to the next amount, and it's going to be 28 weeks. So we're going to have 28 weeks. Okay, the next question. Number 2, this is a speedometer question. The lorry's speed is restricted to a maximum of 56 miles per hour. Use the speedometer to determine this speed in kilometers per hour. So we've got miles per hour here, and we've got kilometers per hour here on this scale. So let's go and, well, you would get a ruler, and you would, from the center, so just to show you, right from the very center, you would draw a straight line crossing 56 miles per hour. So let's figure out where 56 miles per hour is. I'm just going to zoom in here. So we're on this scale here. So this is 50, this is 60. These are going up in ones, so this is 55, so 56 is this one here. So that there is 56. What I'm going to do is, from the very center, just going to draw a straight line through that. And this is quite nice. It goes right through an exact value here. So we have to figure out what that is because the scale is a bit different. So we've got 80 and we've got 100. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 divisions between 80 and 100. So these are going up in 2s. So 82, 84, 86, 88, and it's 90. So right in the middle of 80 and 100 is 90. So that there is 90 kilometers per hour. Alright, question 3. And we got a fractions question. So the crowd at a rugby match was made up of home supporters, away supporters, and people who were neutral. 3/7 were home supporters, 2/5 were away supporters, and the remaining were neutral. So calculate the fraction of the crowd that were neutral. So there are a different number of ways of doing this. The easiest way to do this is to add up the fractions and then figure out what's left from a whole number. So we're going to do 3/7 plus 2/5, and we're going to figure out what this fraction is. So some of you might have heard of the smile and kiss method. So there's the smile, we're going to multiply to get a common denominator. So when we add fractions, we absolutely must have a common denominator. We can't add fractions with dissimilar denominators. That's the number at the bottom. So a big mistake would be to just add the top and bottom. We can't. We have to find a common denominator. The easiest way of doing that is multiplying the two denominators together. So at the bottom, we're going to do 7 times 5. And at the top, this is where the kiss comes in. We're going to do 5 times 3. And then we're going to add that with 7 times 2. So we're going to have 5 times 3 plus 7 times 2, like this. So that comes in. So the denominator is going to be 35. 5 times 3 is 15. Plus 7 times 2 is 14. So we're going to have 29 over 35, like that. So 29/35. We can't simplify that, but what we want to find out is how many 35ths are left. So remaining, so these are the people who are neutral. So we're going to have a fraction that's got 35 at the bottom. What we want to find out is, well, what do we have to add to 29 to get to 35 here? Well, 35 take away 29, right? And so that's going to be 6. So 6/35 are neutral. I'm going to do a quick sanity check just to see if we can simplify this. Is there a number that divides into both top and bottom? In this case, there isn't, so 6/35 will be your final answer there. So question 4, Jeffrey shared his savings between his 3 children, Sophie, Ed and Lucy. The money was shared in the ratio of 7:2:6. So this is Sophie, Ed and Lucy's share. So Sophie received £3,304. Calculate how much money Jeffrey gave to his 3 children in total. So we're looking for the total amount here. So I'm just going to write this out again. So we got 7, 2, and 6. So that is Sophie, Ed, and Lucy. And it says that Sophie received £3,304. And when we've got a ratio part and we know what that part is worth, we can find out what one part is worth and then multiply up. So what I mean by that, what have I had to multiply 7 by to get to 3,304? Well, this is a divide question. I'm going to do 3,304 divided by 7. So we can't get 7 into 3, so we'll try 33. How many 7s go into 33? Well, 4 times 7 is 28. And that leaves us with a remainder of 5. Now, how many 7s go into 50? Well, 7 times 7 is 49. and that leaves a remainder of 1. How many 7s go into 14? It's 2. So one part is 472. Now there's two different ways you could do this. You can multiply now 472 by 2 to find Ed's, and then 472 times 6 to find Lucy's, then add all of those up. A quicker way of doing this is, well, we know what one part is worth, and because we're only looking for the total here, we can add all these parts up, so 7 plus 2 plus 6. 7 plus 2 plus 6 is 15 parts. And we can multiply 472 by 15 to get the total amount. So it's a non-calculator paper. One quick way of doing this is to multiply it by 10, then multiply it by 5, then add them up. So if we did 472 times 10, that would be 4,720. Now we can do 472 times 5, which is just going to be half of 4,720, right? Which we would get 2,360. I've just done that quickly in my head because I'm pretty good at dividing by 2. You could have done a quick chimney sum. That's absolutely fine. So now we're going to add these two up. So we're going to add these two up. And I'm just going to do a chimney sum here. So 0 plus 0 is 0. 2 plus 6 is 8. 3 plus 7 is 10. So we're going to carry the 1. And then we've got 4 plus 2 plus 1 is 7. So 7,080. And so the total is £7,080. All right, so question 5. Eddie runs a stall at the school fundraiser. His game requires 2 spinners to be spun and allowed to come to rest. The spinners are shown. So we've got one spinner here. We've got red, blue, red, green, yellow. So we've got 2 reds there. And then the second spinner here, where we've got the numbers 1 to 5 in the 5 sections. So a prize is won if one spinner lands on blue or green and the other spinner lands on an even number. Calculate the probability of not winning a prize. So I'm going to go over 2 different ways of doing this. One using combined events and one using a sample space table. So the first way of doing it, which is probably the quickest way of doing it, is to recognise that we've got a combined event because it's the probability of winning is the probability of landing on blue or green times the probability of the other spinner lying on an even number. So we're going to figure out the probability of winning a prize first. So the probability, well, I'll just do my pen. So the probability of winning, that's the probability of landing on blue or green times the probability of landing on an even number. So we've got to find out, first of all, what's the probability of landing on blue or green for the first spinner? Well, there's 5 in total, so there's going to have a fraction where the denominator is 5. And how many possible ways are there of getting blue or green? Well, there's 1 blue, 1 green, and so there's going to be 2 in total. So 2 there. Then we're going to times that with the probability of landing on an even number for the second spinner. So how many even numbers are there? Well, there's 2 and 4. And so that is going to be, again, 2 out of 5. So the probability of winning, therefore, is going to be 2 times 2, which is 4. 5 times 5, which is 25. So 4/25. Now remember, we were asked to find the probability of not winning a prize. So to find the probability of not winning, we're going to just find out how many 25ths are left. So basically, if you do 1 minus 4/25ths, which is 25 over 25 minus 4/25ths. And so we're going to have 21 out of 25. So 21 25ths. The alternative way, by the way, that's the answer right there. So the alternative way of doing this takes a little bit longer, would be to do a sample space table, where you're going to have, you just do a quick table. Let's just say, or you've got spinner, so spinner, you could have spinner 2 and spinner 1 at the side here. Doesn't matter which way around you do those necessarily. And this is just a quick table here. So spinner 1, you're going to have so red, blue, another red, yellow, and green. And again, you don't have to have the lines perfect. This is literally just as a way for you to figure out how many possible ways of winning there are. We're going to do spinner 2 now. So spinner 2, I'll just move that up there. We're going to have, and I'll just put that there. So spinner 2, we're going to have the numbers 1 to 5. So 2, 3, 4, and 5. Again, I'm not doing these perfectly. It's just a quick way of arranging this. So let's go back to the question. It asks us, a prize is won if one spinner lands on blue or green and the other one lands on an even number. So let's put a circle for these options. So blue and an even number, or green and an even number. So here we've got blue. So blue and an even number would be this one here. So I'm going to, I'll put a circle there, for that's win. And blue and 4, right? So there's another one. And green. So down here we've got green, and it's green and an even number. So again, green and 2, green and 4. So that's 4 out of the possible. Well, how many squares do I have in total here? Well, it's a row 5 and a column 5. So 5 times 5 would be 25. 4 of which you can win. So the rest of them are ways in which you can't win. Now, you don't have to tick these like this, but I'm just showing you that all these ticks are the ways that of not winning a prize, and of which there's 21 of those. So you do 21 out of 25. So the probability is 21 out of 25. So that's another way of doing it. Whichever way you're comfortable with, they both get you to the same answer. So whichever way you're comfortable with is the way to do that. Sometimes writing it out or doing a table like this is a really good way of visualizing all the different possible combinations. It just takes a little bit longer, is all. Okay, so question 6. Kenny buys a new fridge. The original price of the fridge was £650. The shop is having a sale with 20% off the price of all fridges. When Kenny goes to the shop, he finds there is an additional 2.5% off the sale price. Calculate the price Kenny pays for the fridge, and it's a 3-mark question here. So let me just get my highlighter and let's highlight some important numbers here. The original price. So there's the original price of £650. And it's having a sale with 20% off. So there's the discount right here. So when Kenny goes to the shop, he finds there's another 22.5% off the sale price. So there's another percentage. Calculate the price he pays. So one thing you don't want to do is find necessarily 22.5%. So what you want to do is, first of all, do this in stages, as it said actually. Find 20% and take it away. So find the discount and remove it. So one thing to note is that, well, 20%, again, there's different ways of doing this. 20% off means the price then falls to 80% of its original price. And 20% is 1/5, so 80% is 4/5. So a really smart way of doing this is to find 4/5 of 650. Now again, because proportions, percentages, fractions, they're all different ways of doing the same thing. There are different ways of doing this question. So this is kind of a big-brained way of doing it, but it's not the only way of doing it. I'll go through a different approach after I do this one. So we're doing 650. We're finding 4/5 of 650. So basically what we're doing is we're dividing that by 5. So how many 5s go into 6? Well, it's 1, carry the 1. How many 5s go into 15? 3. All right, so there is 1/5. And so now we're going to times that by 4. So 130 times by 4. So 130 times by 4. Well, you can do 13 times by 4, which will give you a 52, and then just add the 0. So the price of the fridge, once the 20% has been removed, is £520. So now we have to find 2.5% off this. So 2.5%, that is like 25. So if we know 25% is a quarter, we can find a quarter and then just divide that by 10, right? So if you find a quarter of 520, so we're going to find how many 4s go into 520. So how many 4s go into 5? We've got 1, carry the 1. How many 4s go into 12? 3, add the 0. That should be no surprise because that's basically what we've got here, the 130. But that's 25%, that's a quarter. So to get 2.5%, that's going to be 130 divided by 10. So that's going to be £13. And now you take £13, so 520 minus 13, it's going to be £507. Now, the different way of doing this gets you the same answer, and what I've done is try to make life easy for myself, because it's a non-calculator paper, so I've converted percentages to fractions because they're quite easy percentages to deal with. You might be more comfortable just finding 10% first of all. So finding 10% and then doubling it to find 20% and then taking it away. So an alternative way of doing this one, question 6, which most people I think would probably find easier, if not a little bit longer maybe, is, so we got £650 and we want to find 20% of that. So you can find 10%. So find 10%, which is £65. So 20% is going to be 2 times 65, which is 130. And so we're going to take the 130 away from 650 to get £520. So that's the sale price. And then there's another 2.5% off the sale price. One thing people make a mistake with would be to find, well, if you know 10% and you know 20%, is then you can find 1%. But we want to find 2.5% of the sale price, not of its original price. So you want to find, well, 1% of 520 is going to be £5.20. Sorry, I can't do pound signs, it seems. So £5.20. 2% is therefore 2 times that, which is going to be £10.40. And you want to find 0.5%, which is a half of £5.20. So, which is going to be a half of 5.20, which is £2.60. So 2.5% is just those added up. So it's going to be £10.40 plus £2.60, which is £13. And then to find the price afterwards, you're going to do 520 minus 13, which is the £507 there. So two different ways of getting to the same answer. Both are absolutely acceptable. So whichever one you find easier, then you stick with that. Question 7 is on sufficient packing. So biscuits are sold in tins in the shape of a cuboid as shown. The tins need to be packed into boxes with the lid facing upwards. An important point there, which is why it's in bold. There are two types of box available with internal dimensions as shown. So we've got the biscuit tin with the lid at the top. So this dimension always has to be its height, because it always has to be in that orientation. Notice as well that the other two dimensions, so it's length and breadth, they're exactly the same, because it's a square cross-sectional area. So we've got 10 by 10 area. So then we've got box A and box B here. Box A, and notice on the boxes as well, it's got this way up. So again, these dimensions also have to be the same. So that has to be the height. And all we're doing is we're alternating the length with the breadth on both of these. So it kind of saves our job when we go to determine the maximum number of tins which can be packed. So I generally like to draw a very quick table on these things. So let's go, so I'll do the box. So the box, let's go for box A, and let's put the dimensions of box A for this. So box A, we've got 42 and 51. So 42 and 51. Now, I'll do box B. So box B down here, I've got dimensions of 45 and 72. Now let's do the tin. So the tin has dimensions 10 and 10. Why do we not need the height? Why do we not need the height? Well, the height will come into it because it doesn't say anything about not being able to stack those boxes. So notice here that 15 centimetres, we can fit 15 into the 50, so we can stack them on top of each other. Likewise, we can stack tins on top of each other in this box, because 15 goes into 50 3 times, 15 goes into 32 2 times. So whatever box A is, whatever that comes to, we're going to multiply it by 3. And whatever box B comes into, we're going to multiply it by 2. We can do this, so we can put the height. So one thing that we can do is we can just put the height here. So the height of the box is 50. Height of the tin is 15. We'll do this for box B. We'll put the height in, which is 32. And we'll put the dimensions of the tin in as well, which is 15. Okay, so we've got length, breadth, then height. So length, breadth, and height. So I've just done a quick table, and now what we're going to do to figure out the number, we're going to divide. So we're going to do 42 divided by 10 here. Let's put a column here. So we're going to do 42 divided by 10, which is 4.2. So we can only have whole numbers here. So this is going to be 4. So we can only fit 4 in here. 51 divided by 10 is going to be 5. And then 50 divided by 15 is going to be 3. So to find the total number, we do 4 times 5 times 3. We just multiply all those up. which is going 4 times 5 is 20, times 3 is 60. And we'll do the same for box B now. 4.5 divided by 10 is 4.5. Again, we can only get 4. 72 divided by 10 is 7.2, so we can get 7. 32 divided by 15, we can get 2. So we can stack one on top of each other there. And we're going to multiply these up. 4 times 7 times 2. So 4 times 7 is 28. 28 times 2 is 56. And so the total number there is going to be 60. Because that's the maximum number is going to be 60 based on this one. So what we can do is the max is 60. I've squeezed it on at the end there. Okay, question 8. Janet travelled by car from her home to a meeting. She arrived at the meeting at 10:15 a.m. She travelled 136 miles at an average speed of 40 miles per hour. During the journey, she stopped for 50 minutes for breakfast. Determine the time Janet left home. And it's a 3-mark question. So we got speed, we got distance, we've got some time intervals. So automatically I'm thinking speed, distance, time. So if I do, well, you might have seen this, if I do a quick triangle here, you might have seen this. So one thing I think about it is speed is miles per hour, so distance over time, so miles per hour, and so distance is always at the top. So there's always distance over time, or distance over speed, or speed times time. What are we looking for then? Well, what have we got first of all? That's probably a better question to ask. We've got a distance. So we've got miles, so the distance in miles, which is 136 miles here. And we've got a speed. So we've got a distance and we've got a speed. So the only thing left there would be the time. So we can calculate the time based on that. Okay, let's do that actually. Let's calculate the time Janet was travelling for. So the time is equal to the distance over the speed. The distance was given as 136 miles. Speed was 40 miles per hour. Now again, because it's a non-calculator paper, let's make things easy for ourselves. Now again, it all depends on how your brain works. You might prefer to divide by 10 and divide by another 4. Well, actually, that's pretty much what I'm going to do. So instead of doing 136 divided by 40, that's the same answer as 13.6 divided by 4. I've divided both numbers by 10, and it will give me the same answer. So how many 4s go into 13 here? I'll just put a T here. So how many 4s go into 13? Well, 4 goes into 13 3 times, with a remainder of 1. And 4 goes into 16 4 times. So 3.4 is the answer there. So 136 divided by 40 is 3.4. What is the unit? Well, we've got the distance in miles, and we've got the speed in miles per hour. So the time you get from the speed, it's per hour, it's hours. So 3.4 hours. That is not, by the way, that is not the same thing as 3 hours, 40 minutes. So that is not what that is. It's 0.4 hours. So to calculate what that 0.4, well, it's 3 hours, absolutely, but it's 0.4 of 60 minutes. So it's 0.4 times 60 minutes. Because remember, there's not 100 minutes in an hour, there's 60 minutes. So you take the decimal, the 0.4, and you have to multiply that by 60. Well, again, non-calculator, let's make things easy for ourselves. 0.4 times 60, well, because I'm timesing, if I do 4 times 6, so I've multiplied 0.4 by 10, but I've divided by 60 by 10. So 0.4 times 60 is the same thing as 4 times 6. So 4 times 6 is 24, so that's 24 minutes. So this is 3 hours and 24 minutes. So that's the time that Janet was driving for. Let's go back to the question. Okay, so Janet travelled by car from her home to a meeting. She arrived at the meeting at 10:15. During the journey, she stopped for 50 minutes for breakfast. Determine the time Janet left home. So we want to get a time interval here. So this 50 minutes, here, we can add that on to this time here. So we can go plus 50 minutes. And this will tell us the total time that she was travelling for, including the time that it took her for breakfast. So 3 hours and 24. What I do, first of all, is do 3 hours and, well, I'm going to do 50 plus 24, which is 74 minutes. Now remember, every 60 minutes, it carries over to the next hour. So that is going to be 4 hours. I'm going to take 60 away from 74 to get 14 minutes. Okay, we're not done quite yet. That's 2 of the 3 marks. Now we have to figure out the final part of that question is to determine the time Janet left home. Well, we've got a time that she arrived, so we just have to work backwards from the time interval that we got. So let me just remind myself, it's 10:15 in the morning she arrived. So what we're doing is we're doing 10 hours, so 10:15, and we're taking away from that 4 hours and 14. So we're going to get 6:01. So Janet left at 6:01 a.m. I've put it in AM, PM notation because that's what the question had given me. But you can clearly see here that 24-hour rotation is exactly the same thing. So that's absolutely fine as well. Okay, question 9. So the design for a skate park ramp is shown. The height of the ramp is 70 meters. So we got our height there, 70 meters. To be suitable, the ramp must have a gradient of 0.35 plus or minus 0.01. So we got a gradient given to us in tolerance notation there. So we got a gradient in tolerance notation. So the question's asking, determine whether the ramp is suitable. Use your working to justify. So again, we can't just say yes or no, it's suitable. We have to clearly show. So the thing to remember is the gradient formula. So the gradient, that is equal to the vertical distance divided by the horizontal. And so the gradient of the ramp is going to be, now we have to be careful here, so let's look at the vertical. That's in centimeters. So the vertical is in centimeters. The horizontal is given as 2.1 meters. So 2.1, we have to have centimeters with centimeters or meters with meters. So either convert centimeters into meters or this meters into centimeters. I'll do that. So it's going to be 210 centimeters. So it's going to be 70 over 210. We can do some simplifying now. I can just get rid of the zeros there. So that is going to be 7 over 21. We recognise that 7 is a factor of 21, or 21 is a multiple of 7. So we can divide top and bottom by 7. to get 1/3. And 1/3 is going to be, and we're going to convert it to a decimal, it's going to be 0.333, so 0.33 recurring. Okay, so this is the gradient of the ramp. Now let's compare that with the ramp suitability, or the suitable gradient. Well, we're given it as intolerance notation, so we're going to find its upper and lower bounds. So so the suitable gradient is, so it's going to be between, because we've got an upper and lower bound, so 0.035 minus 0.01 and, sorry, I put 0.035, I put an extra 0 there, my bad, and 0.35 plus 0.01. We can see that the second decimal place there is 1, second decimal place is 5, so it's going to be 0. I'll do my pen. It's going to be 0.34 and 0.36. So if we look at the gradient, so the suitable gradient has to be between 0.34 and 0.36. The gradient of the actual ramp is, well, it's 0.33. I'll do that to 2 decimal places just to keep in line with the gradient there, the tolerance between 0.34 and 0.36. Well, 0.33, so 0.33 is actually less than the lower gradient level, the lower limit of the gradient. So so since 0.33 is less than 0.34, the ramp is not suitable. Okay, question 10. John owns a bike shop and has a team of mechanics who build each new bicycle. The table lists the tasks that need to be completed and the time required for each task. So we've got tasks A through J down here. And we've got a preceding task, so this is a precedence table. And we've got a time in minutes that these tasks take. The question is asking us, so part A is asking us, complete the diagram below by writing the tasks and the times in the boxes. So we've got a network diagram here in which we're going to have to complete this. And we can see that the last task has actually been done for us. So task D right here, put bike on display, and it's got its preceding tasks. So this takes a little bit of problem solving. The first step is to figure out what the first task is. And the first task is always the one, and sometimes there's always a few starting tasks. This time we've only got one, so it's always the one that has no preceding task, because there's no box before it, right? There's nothing that connects onto it. So the preceding task is, well, I have none, and so we're going to look at the preceding tasks, and we're going to find the one that says none. And so this is F. Remove bicycle frame and parts from the box. Time 2 minutes. So that's what I'm going to put in the first task here. I'm going to put F, and I'm going to put 2 down here. And I'm really just copying what they've shown us here. So the letter at the top, number at the bottom. Now we're going to have to figure out what comes after F. So there are 2 branches. So we got the top branch and we got the bottom branch. We're going to have to look at the preceding task. What I'm going to do, because we've got D and we've done F, I'm going to put a little tick there. So now I want to look at what 2 tasks have F as their preceding task. So we've got task A and we've got task E right here. So A or E. Now it's just figuring out which one goes in which. Do we put A in the top one or do we put A in the bottom one? And this all depends on, well, if we look at this one, so this box here, so the one at the bottom, this has one task that goes after it. So we're going to look at a step ahead, and we're going to see which task has one preceding task, or which one task has either A or E. And if we look at the top one, it's got 3. So there will be 3 tasks that have either A or E as its preceding task. And it'll be that preceding task which will go here. So to figure that out, you kind of have to be a little bit intelligent, think a step ahead. So let's look at A. We can see that A has 1, 2, and 3 tasks which it comes before. And E, that was the other task that has F as the preceding task, it only has 1 task which comes after it. So because A has 3 tasks which follow it, A has to therefore be in this one. And I'll put the 1 there. And E, was it 1? Yeah, minutes in 1. And E, which is also 1 minute there, I'll put E, that goes down at the bottom. So we can go ahead and find the following task after E, because there was only 1, and it was this one here. And that is G for 1 minute. So we can put G 1 minute after E. Now let's do A. Now you can see we're going to have a similar problem to solve for the following tasks for A, because we've got 3 tasks in which A is the preceding task. One of those tasks doesn't have a following task except for D, so it only has D. We've also got 2 tasks which have 1 more following task. So let's go up to the table and let's see all the tasks in which A is its preceding task. So we've got task B, we've got task B, we got task C, and we got task H. Okay, so we have to think about this. So let's start with B. So grease pedals. How many tasks have task B as its preceding task? So now I'm going to look for B, and you can see there's only 1 task in which has B as its preceding task. So we're going to have B, and then we're going to have J. Okay, let's go to the next one, which is C. So we've got C here. How many tasks have C preceding it? We've got 1, which is I. So we're going to have C and then I. And then let's look at the other one. We've got preceding task A, which is H. So how many tasks have H preceding it? It's none other than the D here. So therefore H, before it gets to D, doesn't have any more tasks after it. So H would have to go here. And we're going to have B and J here, and C and I here. Or it doesn't really matter, you can have those 2 the other way around. So I'm going to put H here. So H, let's have a look at how many minutes it was. It was 5 minutes there, so H is 5 minutes. So let's go, so I should be ticking these off really. So H, E, G, and A. Okay, so let's have a look at the other one. We've got B. So we got B, and what did we say? Well, here's B, and it's J is also, so B precedes J, so it's going to be B then J. So I'm going to have B, and then J here. So B is at 1 minute, and J is at 3 minutes. And we've got C. So we've got C and we've got I, because C precedes I, so it's going to be C and I. And C is 7 minutes and I is 4 minutes. And that is the diagram completed. So we'll just make sure we've got everything here, I and J, and then it's just D, which is already completed for us. So that's part A. complete the diagram. There's a part B to this. So John thinks that his team of mechanics will have the bike ready within 15 minutes. To determine if John is correct, use working to justify your answer. So this is a critical path question. So we want to find the critical path through this. So let's look. So the critical path is the longest path. Every time you branch off, you want to take the longest. So let's have a look at the options. So to start off at F, we can either go up here or through here. So which is longer? Well, this is 2 minutes. So E and G, so the lower path there, only takes 2 minutes. So we can already see that this path, this upper branch, is going to take the longest. So it is going to go in this direction here. Now we have to figure out, now we've got 3 options. Is it going to go through B and J? Is it going to go through C and I? Or is it going to go through H? Well, let's count. So 1 plus 3 is 4. 7 plus 4 is 11. And that's 5. So it's going to go A, C, and I here. So it's going to go through A, C, and I, and then it's going to go to D. And then it's going to go to D. So what we want to do is add up that path, including D. So we're going to have, so the critical path is, so the path is F, A, C, I, and D. Now let's put the numbers. So F is 2, A is 1, C is 7, I is 4, and D is 2. And so we're just going to add those up. So we're going to add all those up. So 2 plus 1 plus 7 plus 4 plus 2. And so that's going to be 16 minutes. So 16 minutes. And what did John say? Well, he said 15 minutes. So he was not far off, but he was still off. He was still wrong. So John is incorrect. Question 11 is a pie chart question. A survey was conducted into favourite pie fillings. The results were 80 people for apple, 40 people for cherry, 60 for lemon. Construct a pie chart to illustrate this information. So the first thing is to remember that a full circle has 360 degrees in it. So we want to find the angles to construct each of these 3 fillings. So let's do apple first of all. Well, actually what we need before we even do this is the total number of people in the survey. Because we're going to have to add all those up to find out what each person represents in degrees. So 80 plus 40 plus 60, so 80 plus 40 plus 60, that's 180 people. So 180 people represents 360 degrees. So one person, so 180, so let's have a look. 180 is 360 degrees. So if you divide, so 360 divided by 180, that's going to be, that's degrees, 2 degrees. So one person in the survey represents 2 degrees. So what you want to do is now calculate apple, so each of these individual angles. So apple is, so it's going to be, so if one person is 2 degrees, 80 people is going to be 160 degrees. Cherry. So cherry was 40 people, so we're going to do 40 times 2 degrees. That is going to be 80 degrees. And then 60 people for lemon. So lemon is 60 times 2 degrees, which is 120 degrees. Now, I can't show you how to do this on my iPad, But you start at the centre and work clockwise. So apple is 160 degrees, cherry is 80 degrees, and lemon is 120. So I won't be able to show you how to do this on my iPad, but you would just get your protractor and measure these out as best you can. Now I'm going to do a very rough sketch of this. So a very rough sketch of this would be something like this, where you've got apple, cherry, and then lemon, like that. So question 12. Laura makes and sells fruit smoothies. She intends to buy kiwi fruit in bulk. She considers the following two options. So option 1, 35 kiwi fruit for £5.95. Option 2, 45 kiwi fruit for £8.10. Determine which option offers the best value for money. So there's a smart way of doing this. What you might think, 'cause it's a proportion question, and you might think, okay, let's figure out what it costs for one kiwi fruit. But dividing by 35 and divided by 45, it's quite difficult. So think about this in terms of fractions. So option 1, we've got, so it's £5.95 per 35 kiwi fruit. And we're comparing that with option 2, which is £8.10 for 45 kiwi fruit. Notice I've converted these to fractions for a reason. I want to show you that when we're comparing fractions, we can only compare fractions like for like denominators. So we've got different denominators here. So we want to find a common denominator. So basically we want to compare fractions where the bottom number is the same. So I noticed that 35 and 45 are both multiples of 5. They both end in 5, so they both divide by 5. So I can actually say that, okay, let's figure out what the price is per 5 kiwi fruit. So what have I done to the first fraction, the denominator, to get it to 5? Well, 35 divided by 5 is 7, so I've divided that. So I've divided that by 7. And I've divided the second fraction by 9. 45 divided by 9 is 5. So now I have to divide £5.95 by 7 and then £8.10 by 9 to figure out what they cost for 5 kiwi fruit each. So let's do option 1 first of all. So what I'm doing is I'm doing 7 into £5.95. So how many 7s go into 5? We can't do that. So I'm going to put a 0 there. And I'm going to carry that 5 over to the 9. So how many 7s go into 59? Well, 7 7s are 49, 8 7s are 56, so it's going to be 8. And we're going to have a remainder of 3. So how many 7s go into 35? Well, it's 5. So we've got 85 pence. So 85 pence for 5 kiwi fruit. So that's option 1. Let's do option 2. So option 2 now, I am looking to divide £8.10 by 9. So how many 9s go into £8.10? Well, again, I'm going to have 0 there, carry that over. How many 9s go into 81? Well, it's 9. And then that's 0, so I'm going to have 0 there. And so that is, so option 2 is 90 pence for 5 kiwi fruit. And so we can clearly see that option 1 is cheaper. So option 1 is the best value. Question 13. Senior students are preparing to sell scented candles at the school fair. Before ordering the candles, they carried out a survey to find out which scent people preferred. The results of the survey are shown below. So we've got a table, preferred scent of the candle, we've got linen, vanilla, rose, cinnamon. Then we got the percentage of people that preferred them. So 50% preferred linen, 35% preferred vanilla, 10% preferred rose, 5% preferred cinnamon. The question continues. The students sell 180 candles in total. They sold 65 vanilla scented candles. Determine if this is more or less than expected. So this is an expected frequency question. 2 marks. So let's find out how many were expected. So the first thing we want to do, because we're comparing the actual with the expected, let's calculate the expected. So we're talking about vanilla, and here's the vanilla percentage, and it's 180 in total, so it's 35% of 180. So 180 times 35%. Okay. So if we know that 5%, so let's figure out what 5% is. So we know 5% is 1/20th, because there's 5 20s and 100. Let's calculate that, and then we're just going to times it by 7. So we're looking for 7/20th. So let's figure out 5%. So we're doing 5% of 180. So that is going to be 180 divided by 20. That's going to be 9. So that's 5%. Remember, we're looking for 35%. So we're going to have to times that by 7. So 35% is just 5% times 7, which is 9 times 7, which is 63 candles. So that was the expected. What was the actual? Well, it was 65, which tells you right up here. So 65 is the actual. So actual is 65, expected 63. So they sold more than they expected. So they sold more than expected. Now, there are different ways of doing this question. I think this is probably the more straightforward one. You could have found 10%, found 30%, found 5%, different ways of doing it. I thought finding 5% is just finding 1/20th, so dividing 180 by 20 is pretty straightforward. And because 35% is 7 times that, then I multiplied by 7. But again, there's many different ways of doing percentages. You might have preferred to have found 10%, multiply that by 3 to get 30%, halve 10% to get 5%, and then added them together, which is absolutely fine. So don't feel that this is the only way of doing it. There's many different ways of doing this kind of question, as long as you get the right answer. And don't forget, you need to have the conclusion at the end as well.